Hi, this is 2016 Amc 10B, number 25. Okay, so some students they email me to explain this question a little in detail. Okay, maybe yeah, I can go slow. Okay, to figure out completely. Okay, how we start these questions. Okay. So before we start, we need memorize some properties. Okay, the first one, when you have on the number line over here, you have some x over here. This x has what integer portion. Okay, this is integer portion. That is what greatest integer function. Isn't it? Integer portion and decimal portion. We have you can divide this x is what in terms of these two integer portion and decimal portion. When you have 3.14, integer portion is what? 3, isn't it? Yeah, 3 is 3. And decimal portion, 0.14. You can separate always. Okay. And also, this is one of this one. A second one is when you be inside 3.14. But this is integer, we know that. But this can be separate because inside is 3.14, isn't it? When you have a greatest integer function, okay? But this number is already integer, they can move out. This is just what 3 plus 0.14. You can separate this way. Is it okay? Actually, greatest integer function of this number 3.14 will be 3. Okay? But this is 3. This is 0, right? Okay? That is true. So we need memorize this two. Okay? Now I'm gonna simplify this one. Take a look over here. Integer k times x minus k times integer x. Now simplify this one. You know what is the k? What is the x? X equals to what? Integer portion and plus decimal portion, right? So we times k, right, to the both terms. So when you multiply by k, it looks like this way. Integer k times integer plus k times decimal and minus k times integer. Okay, when you take inside this integer first one over here, okay, this number should be integer, right? Because why k is integer, this is also integer. This integer portion can move out. Okay, can you see over here? So this one can be expressed this way. K integer x plus integer k decimal and minus k times integer function of x. Okay, so the first term and third term can be cancelled out. All right, this is cancelled out. Finally, we got this one is integer k times x. That's it. This is very familiar, right? Okay, now put this number in the equation. Okay, so f of function f of x now can be expressed this way. Sigma over here. Okay, when you pro, I'm gonna write that one more time. That's better. K equals 2 to 10. Index number is k, and the function is what is that? K times decimal this one. Okay, now put this number k 2 to the 10, right? The first one should be equal this way. 2 times x plus 3 times decimal 4 times, and keep going. You're gonna finish up to what? K equal 10, right? That's it. Okay. So case 1, what is this? What this value? What is this value? How many different values are there? If decimal is what, from 0 to 1/2, I'm gonna write that. This one is decimal portion from 1 to 0 to 1, not including 1, okay? If this decimal is up to 1/2, 2 times 1/2 is still 1, but less than 1, still the value of this one is 0 over here, right? But after 1/2, from 1/2 is what? 2 times 1/2 is what? That is 1, right? So after 1/2, that the greatest integer function always 1. It has what? Integer is 1. We have 2 different values up there. Okay, keep going, same thing. 3 over this one. At this times, we have what? 3 interval, right? 1 divided by 3 is what? 1/3 of it. They're gonna up on this bar, they're gonna change the numbers. Before 1/3, that is 0. After 1/3, you can multiply. You can just check, right? 3 times 1/3 is 1, right? From here is 1, okay, and up to 2/3. From 2/3 before 1, it's gonna be 2. You know, we have 3 different numbers there. Okay. Okay, one more. 4. This number. So 4 is what? 1/2, 4 numbers, 1/4, and 3/4 over here. Definitely less than, okay, 1/4 is gonna be 0, right? After 1/4 times 1/4, 4 times 1/4 is 1, 4 times 2/4 is 2, 4 times 3/4 is 3. We have 3 different numbers there, right? But this is some sigma, right? Or summation. Okay? But when you take over here, from 0 to 1/4, when you add all this one, okay? When you add all this one, only 2/34 only, okay? When you add this one before 1/3, it's gonna be sum of numbers is what? 0, isn't it? 1/4 to 1/3, what happens? But this is up to here 1. The other two is still 0, but this is 1 over here, right? So this is 1. Okay? Okay. From 1/3 to 1/2, this is 1/2 over here. They have another different number over here. This is 0, but this is 1. This is also 1, that is 2, isn't it? Okay, now check out the next one. From 1/2 to 2/3. This is now 1, right? This is now 1. This is also 1. This is now 2. Total is about 4, right? Okay, from 2/3 to 3/4 over here. This is now 1. This is 2 over here, right? Okay, this is 2. From here, this is still 2. That is 5, okay? 1 plus 2 plus 2 plus is 5. From 3/4 before 1 is, this is 1, 2, 3, 6. Okay? You can see that over here. How many different numbers? 1, 2, 3, 4, 5, 6 different numbers are there. How can you find these 6 numbers? You can find what? Space. 1, 2, 3, 4, 5, 6. Okay? Another way, also you can find the number of bars. Where is the bar? This is bars. You start this bars, okay? I'm gonna use color. 1, 2, 3, 4, 5, 6. This is not okay. Include these numbers. When you find the number bars, this number bar is actually a number of space, which is a number of distinct numbers. Okay? Okay, now let's decide how many distinct bars there. Actually, this bar is the same numbers. So we count only one bar, right? So another one is on this bar, they have a different number. Left, right, different number. On this bar, left, right, different number. On this bar, left, right, different number. Okay? So our goal is how many distinct bar out there. You have to check it out. Okay? I'm going to use some number here. 2 first. I'm going to use 2 first. This is 0, 1. When you have two bars over here, okay? 0 and 1/2. On these two numbers, there are 2 bars, 0 and 1/2. When you have 3 bars, 0, 1/3, 2/3, right? When you have 4, this is 2. 4 is what? 4 bars there. 1 pulse, 2 pulse, 3 pulse. That's it. The next one, 5. 1/5, 2/5, 3/5, 4/5. 5 bars there. Keep going. 6 is what? 1 6, 2 6, 3 6, 4 6, 5 6, 7, 1 7, 2 7, 3 7, 4 7, 5 7, and 6 7. We have 7 bars. 8, 1 8, 2 8, 3 8, 4 8, 5 8, 6 8, 7 8. Okay, 9, 1 9, 2 9, 3 9, 4 5, 6 7, 8. We have 9 bars. There are 10. Actually, there are 10 bars. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7 10, 8 10, and 9 10. That's it. But we're going to eliminate what? Same bar on the same position, right? Okay. Now we have count the bar. The first is what? 0. There, same bar out. When you have 1/2, which number has the same bars? 2 poles. Okay, 2 poles is out. 36 is out. 4 8 is out. 5 10, they are all 1/2, right? Now check it out. 1/3. Okay, 2 6 is out, right? 3 9 is out. This is what? 4 6 times 3 times 3, 6 9. They are same location. Okay, check out this one. Check it out. 1 4, 2 8s, right? That's all? Yeah, that's it. Times 3 is what? 3/12. That's not 12 in denominator. Okay, 3 4, 6/8. That's it. 1 pips, 2 pips, 2 10, right? Okay. 2 5, 4/10. 3 5, 6/10. 4/5, 8/10. What about 1 6? 2/12, that's not 2/12. That's all. We just eliminate the bars on the same locations. So we're gonna find how many distinct bars are there. Okay, so we're gonna find. So we already got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. but there are no answer 31. Let me check it out. Oh, 32. We missed one. Let me check it out, okay. 16, 17, 18, 19, 20. Oh, I mean the 21 over here, right? 22, 23, 24, 25, 26, 27, 28, 29, 30, and 32, right? We have 32 distinct parts. So there will be about 32 distinct parts there, okay? Yeah. So that's why 32 is the answer, okay? Let me see. Okay. So I hope, right, you understand this one, okay? All right. Thank you so much. I'll see you next time.